Bienvenidos, Ushamadid, and welcome UMGC learners in the CMIT-455 Section 6380 course. This is the CCNP ENCOR version 8 Cisco Networking Academy course for the spring 2021 semester. In this packet tracer tutorial, we're going to be going over packet tracer activity 1.2.1, where we take a look at the Inter-VLAN Routing challenge. Now, in this tutorial, we're going to be discussing a number of different approaches that can be used to achieve Inter-VLAN routing. And so let's take a step back. What do we mean when we say Inter-VLAN routing? Well, if we have segregated or sliced up this physical switch, switch 1 right here, into multiple virtual local area networks, in other words, VLANs, we have VLAN 10 and then VLAN 20 and VLAN 30, with a layer 2 switch, which switch 1 is a pure layer 2 switch, we would have segregation where VLAN 10 could not talk to VLAN 20, could not talk to VLAN 30. And that is how we separate broadcast domains, or in this case, we have subnets. And so I want you to think a VLAN is a subnet, is a broadcast domain. And with VLANs, which is a layer 2 construct, we are segregating these hosts out from one another. And so the hosts on VLAN 10 cannot talk to VLAN 20 and vice versa, and 20 can't talk to 30 and vice versa, and 10 and 30 and so on. And so hopefully that concept is clear, that a virtual local area network is nothing more than carving up a switch into individual mutually exclusive broadcast domains. Now, what happens when we want to have communication between the different VLANs that exist? Well, there's a number of ways that we can do that. This activity is going to walk us through how to do it via router on a stick. And this is where we take a single physical interface on router 1 and we logically divide that interface up into multiple logical interfaces. And so you can see the physical interface is gig 01. However, we create sub interfaces .10, .20, .30, .88, .99. And so from a single physical interface, we are able to create 5 logical interfaces. And since this is a router, that will allow us to do inter-VLAN routing, because all the VLANs will congregate at this individual point right here, which is router 1, at which point router 1 will do what routers do, and that is it will route packets. And so let's go ahead and dive into this activity, and we'll talk a little bit more on the different approaches you could take. You don't always have to do router on a stick. So on this activity, and you'll get used to the layout of the packet tracer activities throughout the course, but typically we have an instruction section that will be started with an addressing table. And in some cases you have all the information, and in many cases you don't. Maybe you're going to have to figure out what that information is. Then we have our VLAN breakout here. And this is being provided because we're going to be doing some work excuse me, with VLAN creation. So let's jump down into the instructions and dive in to this activity. So we're going to assign IP addressing to router 1 and switch 1 based on the addressing table. So here's our addressing table again. So let's go ahead and we'll start with switch 1. Now, we are on the command line interface here for switch 1. We'll give ourselves a little bit more room. And so you can see here, switch 1, VLAN 99 is going to have the following IP, And then you can see the default gateway. And I'm going to talk about this because this is a very important concept. It's also a concept that is misunderstood by a number of learners. So let's go from user exec mode, which is indicative of the greater than sign there in the prompt is indicative of user exec. The enable command puts me into privilege exec. Conf T, or configure terminal, is going to put me into global config mode. And so from global config, I can make the configuration changes required. Now, remember I said, if we say do show version, you can see that we are on a 2960. Now, this is a pure layer 2 switch. And so what I'm about to do sometimes causes confusion with learners. I'm going to create a virtual layer 3 interface. Now, you might be saying, well, how can you do that if it's a layer 2 switch? Well, layer 2 switches support the creation of layer 3 virtual interfaces. And those virtual interfaces are referred to as SVIs, or switched virtual interfaces. And they allow me, in some instances, to manage the switch. And so if we had, and remember, this is going to be for VLAN 99, and you'll notice that nothing is connected to VLAN 99 here. So you might be asking yourself, well, why are we doing VLAN 99? Well, I want you to think about this. What if I decided, and I'll draw it off here, we connect in another PC, and we'll say it's PC 99, and that PC is going to be the management PC. That is how I'm going to manage the switch. And then we would give it a 172.17, and again, we could go any subnet that's not used, but it would make sense here logically to say .99.0/24. And that would be our management VLAN. And in fact, if you look here, you can see in the VLAN table, that is exactly what they're calling out here. And so I'm going to be able, I could manage it with this PC, but we're doing inter-VLAN routing, which means that the traffic from PC1, if PC1 wanted to manage the switch, I would go ahead and either telnet or preferably SSH to 172.17.99.10. However, if it's PC1 that does that, the traffic will transit through the switch, come to the router to be routed because we're going between VLANs, inter-VLAN routing. And then the router would say, yeah, I know exactly how to get you to that IP address. I have a sub interface, and then I know that that is where the traffic is going to go. And so that is how you could manage the switch. And that's why you don't see a PC99 here, because we're going to be able to manage that switch from any of these PCs, theoretically, if that's what we wanted to do. All right, so let's clear the screen. Let's come back down to the command line prompt. And so here is interface VLAN 99. This is the switched virtual interface. Now, you're also going to notice that the interface does not come up right away. So let me go ahead and say IP address 172.17.99.10, and it's a /24. So 255.255.255.0. The first 24 bits are indicative of the network, and then the last 8 bits of the 32-bit dotted decimal subnet mask are the host bits. So there's the IP address, but you'll notice if I say do show IP interface brief and we come down here to VLAN 99, you'll notice that it is down. Now, it's down because the VLAN is configured. However, there are no ports, either host ports, access ports, or trunk ports that have VLAN 99 configured to transit them, right? Or in the host case, we don't have a host on VLAN 99. Excuse me. And so the auto state feature of the VLAN is going to keep it in a down state until we have a port or this VLAN is allowed to transit a trunk link that is when you will see this interface come up. Because even if I say no shut, you see nothing's happening, right? So let's take a look at the do show IP interface brief. Again, even with a no shut, it is showing down, down. And again, if it was shut down, we would see administratively down. So we know that it's not shut down because it shows the layer 1 and the layer 2 as being down and down. It would be administratively down if it were shut down. I said no shut to show you and to prove to you that this interface, this switched virtual interface, this virtual layer 3 interface on the switch is going to stay down until we have either an access port in VLAN 99 or it's on the trunk port, which is going to be this link right here. And that is our stick, right? The router on a stick, and the stick is a trunk port. And we'll talk about here in a second. So we've added the IP address to router 1. However, we've got this default gateway. So let's go ahead and exit out. And I'm going to say IP default gateway 172.17.99.1. Now, this is also one of the most misunderstood configuration commands on switches. That command right there, the IP default gateway command, that is not setting up a default gateway for these PCs. That is not what's happening. Let's look at PC1. PC1 already has its default gateway. What about PC2? PC2 has a default gateway. PC3 has a default gateway. And you'll notice that all of those default gateways are different, and they all correspond to the IP address of the sub interface for that VLAN as represented on the router. And so if that command on switch 1 is not setting the default gateway up for all of these hosts down here, then who is it setting the default gateway up for? And the answer to that question is right here. It's setting the default gateway up for the switch. And here's how I want you to look at that command. So when I say IP default gateway, and I put in the 172.17.99.1, and if you look up here at our addressing table, that is the sub interface gig 01.99 on router 1. And so this statement is basically setting the default gateway for the switch, and specifically for the switch's control plane traffic. Traffic that would be generated by the switch. So when the switch, or if you're on the switch like I am right now, if I try to telnet to router 1, or if I try to SSH to router 1, or if I try to ping this internet server, this is the default gateway for that traffic. Traffic generated by the switch. That is very, very different from what we refer to as transit traffic. And by definition, transit traffic is traffic that is transiting or going through the switch. So transit traffic is if PC1 tries to SSH to router 1. Transit traffic is if PC2 tries to ping the internet server. Transit traffic is when PC3's traffic transits through switch 1 to try to pull up the web page on the internet server. Transit traffic passes through the device. It is transiting through the device. That is very different from traffic being generated by the device itself. And so hopefully you see the difference between the two. And so all that command right there is doing is the exact same thing that this configuration does for the PC. So in other words, that configuration command for the switch is the equivalent configuration command of that for the PC. It's giving the device a default gateway so that if that device is generating traffic and it doesn't have a specific match for that network, it knows where to send the traffic. And again, it's kind of like, think of it as a Hail Mary. We're basically saying with a default gateway configuration, hey, if I don't know specifically how to get to that network, then I'm just throwing it downfield. I'm pushing it over the fence to this other IP address, my default gateway address, and I'm going to let the default gateway deal with that traffic and try to figure out where it's supposed to go. And by setting it to the router, and that's what routers do, they route traffic, the router will figure out where that traffic is supposed to go, or we're hoping that it's going to be able to figure out where it's supposed to go. But that is all this statement is. Learners will see this statement and they immediately think, oh, all the traffic from PC3 and PC2 and PC1, when it gets to the switch, this command tells the switch to send all that traffic to this interface on the router. That is not what is happening, right? Remember, the PCs already know where they're sending their traffic to if they don't have a route to that traffic. All right, so hopefully that makes sense. And it's a very important point because that command on that switch causes a lot of confusion with learners when they see that for the first time. All right, so we've put our IP default gateway statement on there. Now let's address router 1. And there's going to be a little more work involved here, and there'll be one twist in the plot when we do the configuration here on router 1. Again, as indicated by the greater than sign, we're in user exec mode. If I enter the enable command, that's going to put me into privilege exec, which allows me to get into global config by saying configure terminal, or I simply just say conf t, C-O-N-F space the letter T. All right, so we're now in global config mode. Let's say do show IP interface brief, and let's see what things look like right now. Well, here is the gig 00 interface, and you can see that that is up, and we can assume that this is that gig 00 interface. In fact, if I hover over that link, if I click into the packet tracer activity and hover over the link, it shows me the two connections involved here. And so we have just confirmed it's gig 00. If you were to have hovered over that and it didn't work, what is a conclusive way, other than seeing that that's the only interface that's up? Maybe we have had other interfaces that are up, but you can conclusively see that that is the gig 00 interface by simply going into that interface and shutting that interface down. And as you can see right there, those upside down triangles indicating we had or I should say the upside down red triangles are now indicating, hey, you no longer have connectivity here. So let's say no shutdown. Let's bring the interface back up. And there we go. Now, spanning tree is why you're seeing this little orange dot here. We'll let that do its thing because we've got other things to do. And that'll change to a green up arrow here shortly. So let's get our interfaces configured on router 1. So I'm going to go into interface gigabit Ethernet 01.10. Whoops, sorry, .10. Now, the reason we're using 10 is not because you have to use 10. And this is another very confusing point, is that the sub-interface number does not need to match the VLAN number for which we are performing inter-VLAN routing on router 1. So for VLAN 10, I could say gig interface 1.8675309, right? If in fact it would allow me to put something in that high. I could put any value in here. However, as a network engineer and someone who wants to make troubleshooting easy, not just for yourself, but for your coworkers, always, always, always match that sub-interface number with the VLAN number for which that sub-interface will be doing inter-VLAN routing, or for which that sub-interface is going to be servicing the VLAN. So 1.VLAN number, right, or gig 01 dot the VLAN number. Because if you're using a bunch of random numbers for the sub-interfaces and you go in and you're trying to troubleshoot, it's going to make things a little more difficult to understand. Now, not impossible, but a little more difficult, as you're about to see. So I say int gig 01.10. Now we know that's going to be VLAN 10. We look up here in the addressing table. all of the information I need is right there. Now, here's the first mistake learners will make. Remember, we're doing a sub-interface. We are logically partitioning a single physical interface on this router to be able to service multiple VLANs. And so the mistake learners will make is they'll say, oh, okay, so I put the IP address on next, 172.17.10.1, and I'll put my /24 subnet mask on here. And what's going to happen is I'm going to hit enter, and the router is going to give me an error message back. It's going to say configuring IP routing on a LAN subinterface is only allowed if that subinterface is already configured as part of an IEEE 802.10, IEEE 802.1q, or ISL VLAN. Now, we are interested in this IEEE 802.1q because that is how VLANs are identified coming across trunk links, is with an 802.1q tag. So traffic from VLAN 10, when it transits this stick that the router is on, which is a trunk link or will be a trunk link here shortly, when the traffic transits that link, it will be tagged from PC1. I shouldn't say PC1's not tagging it. It will be tagged by the switch when it goes across the trunk link. The traffic from PC1 will be tagged with an 802.1q tag for VLAN 10. That way, when the traffic shows up here on router 1 says it's coming into my physical interface, but I need to know to which sub interface does this traffic belong. And that is why we have to put the following command on the sub interface before I can even put an IP address on there. And what that message is telling me is, hey, you're trying to configure a sub interface, but you have not told me who this sub interface actually is going to belong to. And in our case, from a VLAN perspective, from an 802.1q tag perspective, what traffic should this interface be servicing? And so what we say is encapsulation.1q, and you can see I put in the 802.1q VLAN tag, which is going to be 10. Now, very, very important point. Remember, I just said that the sub interface number does not need to match the VLAN number. And that is a true statement. However, when you are specifying the .1q encapsulation, that VLAN tag prepended onto the frame, right? Or I should say that's appended onto your frame, into the frame, that's coming across that trunk link, you do need to match with the encapsulation .1q statement. You have to match the VLAN or it's not going to work. So when you're troubleshooting, you will see questions and scenarios where the sub interface number doesn't match, and the question will be, what's wrong with the configuration? But it's not that the sub interface doesn't match, it's that the .1q tag doesn't match. So once we enter this command in, encapsulation.1q10, I've now told the router 1 interface, gig01, and the sub interface .10, I've told it that you will be servicing traffic that shows up on this physical interface with an 802.1q VLAN tag of 10. In other words, traffic from PC1. Now, I can put the IP address on that sub interface. And again, this is allowing me to maximize my investment in router 1. Maybe router 1 only, well, we saw router 1, I should say, let's say do show IP interface brief, let's be accurate here. We saw router 1 has 2 physical interfaces. Maybe that's all the budget that we had was for 2 sub interfaces. And my office is not that big, right? My small office isn't that big. And so I know that I can do Inter-VLAN routing, maximizing my investment with router 1. And so this is sort of a design question, right? How many interfaces do I need on my router? How much traffic? Is it just web traffic? And then maybe that would be okay to sort of aggregate all of the traffic from these 3 PCs across a single gig link, because again, we're oversubscribed here 3 to 1. Because I believe, and actually I think these are fast Ethernet connections here possibly. We'll have to check on the switch. In fact, let's do that. So if I was to look on the switch, show IP interface brief, I think they're all fast Ethernet. Yeah, so these are all fast Ethernets, right? So we are technically not oversubscribed because 100 megabits a second, 100 megabits a second, 100 megabits a second, that's 300 megabits a second. So in the context of that individual link, which we have not brought up yet, this trunk link here goes from gig 01 to gig 01. So that's a gigabit Ethernet link. That's 1,000 megabits a second. And so the fact that we have 300 megabits a second, theoretically, that could be coming through this link, we still have, again, theoretically, I'm not going to get into the TCP IP overhead and the fact that you're really only going to get about 75% best case scenario when we're dealing with TCP IP. So, but in theoretical terms, we have 300 megabits a second aggregated down here that could be coming through switch 1 at any given time onto this link, this trunk link, which is 1,000 megabits a second, right? So with 1,000 megabits a second, we can easily service the 300 megabits a second that might be coming across that link. So we're not oversubscribed. But what if these were gig links from these PCs? Then we would be oversubscribed 3 to 1. But then you've got to look at what kind of traffic are you going to be sending back and forth? Are we just surfing the web, right? And so these are, again, things that you need to think about. And from a design perspective, for a small office, router on a stick is a brilliant solution to keep your cost down with a lower end router with gig interfaces. And again, we've got one out to the provider, and then we have another one that we're going to carve up into logical interfaces. So let's finish this exercise here of the sub-interface configuration. So gig 01.20, and again, incap.1q 20, that has to match the VLAN for which we want to do inter-VLAN routing here. And then I can put my IP address on of 172.17.20.1. Now remember, these addresses on these sub-interfaces should look familiar. There's the default gateway address we just put on the gig 01.10 interface. Here's the IP address we just put on as the default gateway for PC2. So these IPs will be serving as the default gateway addresses. The router 1 is the default gateway. And then let's go into int gig 01.30. And let's say incap.1q30, and then we'll say IP address 172.17.30.1, and it's a /24. And then we're going to get into, and now you may be wondering, well, what's this gig 01.88? What is that all about? Well, again, let's take a look at our VLAN table here, and we can see that that is the native VLAN. And the native VLAN is the VLAN tag that is applied to traffic that would transit the trunk link without a tag otherwise. So if we have traffic that shows up to go across that trunk link, and you might be asking, well, what kind of traffic, where would that come from? It could come from a hub, right? Because a hub, a layer 1 device, which is simply like a repeater, doesn't understand VLANs, right? The concept of the VLAN is kind of foreign to a hub. And so that's one scenario where you might have traffic that shows up to go across this trunk link with no VLAN tag. And so the native VLAN is there to ensure that any traffic that doesn't have a tag, for whatever the reason may be, will be tagged with VLAN 88. And so this is the one deviation from what we've been doing here, is we're going to go into gig 01.88, and we're going to say incap.1q88. However, we need to make sure that on both sides of this trunk link, the stick on which the router resides knows that this is the native VLAN. And the native VLAN needs to match both on the switch port that we're going to be configuring as a trunk, and if we set it up over here on the router, needs to be the same. And so we say incap.1q88 native. And then finally, let's wrap up here with our management VLAN. Sorry about that. We'll say interface gigabit Ethernet 01.99, and we'll go incap.1q99. Now remember, there is no management, right? So you only name it when it's the, or I shouldn't say name it. You only indicate that it's the native VLAN when in fact it is the native VLAN. Just because it's the management VLAN doesn't make it the native VLAN. In fact, it shouldn't be. Your native VLAN should always be a value, a VLAN number that is not being used for any other traffic. All right, so incap.1q99 and then IP address 172.17, sorry about that, .17.99.1. And remember, that's that same value we use the IP default gateway command on the switch with. We said IP default gateway 172.17.99.1. So if the switch tries to ping something for which it does not have a longer, more specific match or a route to get to, that is where it's going to send the traffic to router 1. And PC1 and PC2 and PC3 will all be doing the same thing. All right, so we've got all of our sub interfaces configured here, I believe. Quick double check here. Now, one last thing. Do show IP interface brief. Now, you'll notice here that we still have the up, the down, right? I like how it's red and then it points down instead of green and pointing up from the little arrow perspective here. What do you notice? Well, take a look. All of our interfaces are down, but this is an easy fix. If I exit out here and I go into interface gigabit Ethernet 01, in other words, if I go to the parent interface, think of it as the root interface, maybe if you're coming from the Linux world. It's the parent interface of all of these sub interfaces, or think of it as, like I said, the root interface for all of these sub interfaces that we've configured here. All I need to do is bring up the parent interface and all of the sub interfaces will come up. Now, you might be wondering, let's say do show IP interface brief. A question that learners often have is, well, wait a second, are you telling me that I either have to have all of the interfaces up or all the interfaces down? And the answer is no. Let me go into, let's say I wanted to shut down, VLAN 30 has been decommissioned. We're no longer using VLAN 30. So I go into int gigabit Ethernet 01.30 and I simply say shut. And that shuts down that individual sub interface on the router. And so here we look at all the interfaces are up with the exception of that individual interface. So we bring them all up universally, but then we only shut down the one sub interface that we're interested in shutting down. If I wanted to shut down VLAN 20's sub interface, I could do that. And then that would have two shut down, administratively down interfaces. So again, it's not an all or nothing proposition when you are shutting the interfaces down. But we need to bring that parent interface up so that all the sub interfaces will be up. So now let's bring that interface back up, or else we're going to have issues with PC3 and VLAN 30. So we've assigned all the IP addressing to router 1 and switch 1. We've configured the default gateway on switch 1. So now let's go back over to switch 1 and let's do some VLAN configuration, because right now, let me ask you, what port are all the what VLAN are all of the ports on switch 1 currently in? And if this switch was just yanked out of a box, thrown onto the network, and we've just plugged all this stuff in, it's pretty clear that everything will be in VLAN 1. Now, VLAN 1 is the default VLAN. VLAN 1 should not be used for hosts. In fact, Cisco best practice is to shut VLAN 1 down, to not use VLAN 1. We should be using other VLANs like 10, 20, 30, 99, 88. Those are the numbers that you should be using. We don't want to use VLAN 1, because it's the default VLAN, and 2, for security concerns. Excuse me, which we will get into later in the course. There are some VLAN exploits that you can use. But again, you do not want to use VLAN 1. It is the default VLAN. It's also the default. It also is the native VLAN by default, right? And so that's why we changed that native VLAN. Excuse me. All right, so here on switch 1, let's start to carve up and create virtual local area networks, or virtual broadcast domains, or virtual subnets, right? And remember, a VLAN is a subnet, is a broadcast domain. So we go into global config, and VLAN creation is very straightforward. We're going to say VLAN 10 name faculty / staff. Now remember, we need these to match exactly or the names, or we will not be getting any of the points for this activity. And then I simply say VLAN 20 name students, VLAN 30 name guest, and then in parentheses default, VLAN 88 name native, VLAN 99 name. Now let me stop right there. I'm sorry. This is let me finish this out. I'll say name management. Now, what did you notice just happened? The interface VLAN 99 changed its state to up. So what is that referring to? Exactly. That's referring to the switched virtual interface that we had created, because there were no ports that were using VLAN 99, and VLAN 99 didn't even exist. And so that's why we saw it as down, down. So now when I say do show IP interface brief and we come to the bottom, you can see that VLAN 99 is showing as up, down, which means from a layer 1 perspective, is the VLAN configured on the switch? The answer is now yes. So from a layer 1 perspective, the interface is showing as up. However, the protocol still shows down because we don't have this interface. And I apologize if I didn't say that the VLAN needed to be created earlier on. It definitely, for the up status in the layer 1 column for status, for that to show up, we need the VLAN created. For it to be up, it needs to be created, and we need an interface, and it could be a host access port or a trunk link that is allowing or has that VLAN configured on that interface before it will actually show that it is up. So right now, I can't ping this interface. And again, we've got some other challenges that would prevent that right now, but that's why it's showing as down. So we create the VLAN, and the layer 1 status goes to up, which means, hey, the VLAN's here, it's created, but we're showing it down because there is no interface that's allowing or has that VLAN configured on that interface. So let's continue here. We've got the VLANs created. We named everything correctly. So now we've got some port work to do. And again, this is going to be where your interface range command is going to save you a lot of time. So I'm going to say interface range fast Ethernet 011 to 17. Now imagine if you were going in to each and every interface and typing the same commands in over and over and over again. While that might help you cement the commands and the order of operations, it's really creating a lot of additional work for you. So use the interface range command to go into all of those ports simultaneously. And so now the commands that I'm going to issue here will be applied to all of those ports in that range, fast Ethernet 011 to 17. And so these should all be switch port mode access and switch port access VLAN 10. And that's what it says right here. Ports should be in access mode. Your VLAN name should match the names in the table exactly. So if they're access ports, and if we're putting them in that VLAN, and you can see here, we know that these are host-facing ports. The only port that's not a host-facing port is this trunk port right here that's going to come off for the router on a stick to the router 1. So what other things can we do from a security perspective? Remember, in chapters 1 through 5 in the text, we talked a lot about the spanning tree toolkit. Well, spanning tree port fast should be turned on here, right? So that the port transitions to the forwarding state immediately. What other settings can we use? How about spanning tree Bpdu guard enable? Because what if someone unplugs that connection and then plugs a switch in? We don't want that. So we put Bpdu guard enable on there. And so defense in depth, guard root, so that if a superior Bpdu were to show up on this port right here, meaning coming from something downstream from that switch, the port would error disable. Right? And that's what we would want, or go into an inconsistent state. And that's what we would want. And so that's a much better, a little more solid configuration, and it incorporates a number of spanning tree features. And these are things that you will see in real environments, in addition to other settings that might be on there. So if I say do show run, take a look at that. All those settings applied to every port in that range. I don't have to go into each and every individual port to make these changes. So let's go ahead and say interface range fast Ethernet 0/18 to 24. And we're going to do much the same thing. Switch port mode access, switch port access access VLAN 20, and then we could say spanning tree port fast. You'll notice that link went to the forwarding state immediately. Spanning tree Bpdu guard enable, spanning tree guard root. All right, now let's go into interface range fast Ethernet 0/6 to 10, and we'll do the same thing. And we'll say switch port mode access, switch port access VLAN 30. And then I'll leave the spanning tree off because you get the idea on the spanning tree command. In fact, let me just put port fast on here. There we go. All right, so we've got all those set up. So now we get down to this gig 01 port where, and actually, let me make a double check here. Create, name, and assign VLANs to S1 based on the port assignments. Access mode. Okay, good. All right. Configure gig 01 of switch 1 as a static trunk and assign the native VLAN. So we're going to create a trunk link on int gig 01. And so how do we hard code it as a trunk? Well, we say switch port mode trunk. Now, if it's hard coded as a trunk, a Cisco best practice is to disable the dynamic trunking protocol, something else that you read about in chapters 1 through 5. And so how do we do that? Well, we would say switch port no negotiate, meaning don't try to negotiate as to whether this is going to be a trunk port or an access port. We have hard coded it as a trunk port. If I say do show interface trunk, you can see here mode is on, meaning I have hard coded it with that command switch port mode trunk. Now, there used to be, and again, with some legacy switches, 3560s in general, or specifically, you would have to set the trunking encapsulation to .1Q because Cisco used to support a Cisco proprietary trunking protocol referred to as ISL, or Inter-Switch Link. ISL is not even an option on newer Cisco switches, and it hasn't been for at least, I would say, one generation. And the 2960 is one of those switches where you don't have to say switch port trunk encapsulate, and you can see that the command's not even there, right? But what the command was switch port trunk encap, and you would either say ISL or .1Q. But we don't have to do that on the 2960. Be aware that on 3560s, on older 3560s, you might have to do that if you run across those. You might have to set the trunking encapsulation to .1Q. 2960 we don't, and we can see that with the show interface trunk command. Now, what else do we see here? We see that since this is a trunk link, we now have a port that is allowing VLAN 99 across that port. And so if I say do show IP interface brief, oops, sorry, let's get that command right there. And we come down and we look at VLAN 99. Now that VLAN 99 is in or is allowed across that trunk link, because that is what a trunk link is by definition. It is a link across which you allow multiple VLANs. An access port, on the other hand, is intended to service a single VLAN. Now, I'm not going to get into the IP phone, or I should say the IP phone, and the word is, there's a word that better describes what I'm trying to say that is escaping me right now. However, voice VLAN. We're not going to get into the voice VLAN right now, where on a single access port, you have a data VLAN and a voice VLAN, right? And so you could say technically, well, hey, that individual host port, it's an access port, it has two VLANs on it. And you're right, it does. We'll keep that, we'll set that to the side right now as a corner case. So here in our environment, we're talking about these host ports where you will typically have a host port that is servicing a single host. Again, the phone scenario is a little bit different, but we're going to set that to the side. But now the switch virtual interface is up. So what if I was to say ping, and again, remember, I'm on the switch. So if I say ping 172.17.50.254, that is the internet server. And I try to ping out to the internet server, is it going to work right now? And you can see that we don't have any connectivity. Oh, wait, and there it is at the very end. And now we do. And again, we're dropping these initial packets here. The period meaning the packet is dropping, that it's unsuccessful. The exclamation mark, right? And I like how they use the exclamation mark because it's like, yes, success. And that's, you put the exclamation mark at the end of it. So we've got the exclamation mark indicating that we have success. But how is it that we had success? We had success pinging from the switch, control plane traffic coming off of this switch, because the switch knows where to send traffic that it doesn't have a route to get to. It sends it to the default gateway, just like PC1 is going to do, just like PC2 is going to do. Now, they're going to send it to different default gateways. All the sub interfaces that we configured, with the exception of the native VLAN sub interface, all of the other sub interfaces are serving as default gateways, meaning let's just get it to router 1 and router 1 will take it the rest of the way. Hopefully, right? As long as router 1 is configured properly. And so that's why we're able to do that right now. So we configured interface gigabit Ethernet 01 as a trunk port. We hard coded it. We also said switch port no negotiate. We turned off DTP. Now, something else that we might be able to do is, what about switch port trunk? And let's see what options we've got. We could allow certain VLANs across the trunk link. So maybe I want to get on here and say 10, 20, 30, 88, and 99, and only allow those VLANs across. That's a good practice from a security perspective, especially if you're in a static environment, right? But we're interested in the native VLAN. Remember, that native VLAN needs to match on both sides of the trunk link. If it doesn't, you're going to start seeing log messages, syslog messages. Excuse me. Oops, sorry. VLAN 88. And so now we've set that up so that it matches on both sides. And so let's go ahead, even though we're not going to get points for this, it's not asking us to do this. I'm going to say switch port, trunk allowed VLAN. And you can see, I can add VLANs to an existing list. I could say all, to just say all VLANs. Now, all is the default. So if I say all, and then we say do show run. Remember, these default settings can be tricky. Take a look. Where on that interface do you see switch port trunk allowed VLAN all? You don't. And that's because it's a default setting. Cisco defaults 99.9% of the time will not show up in the running configuration. And I'll be very careful to say running config, because there's a command that you can run, and I'll show you this command, a great command. And I don't believe, and I'm not even sure Packet Tracer supports it, and it doesn't. However, never fear, we have some real Cisco devices here, and hopefully I'm able to get onto one of these, and here we go. So I'm on router 9. This is a real Cisco router, physical Cisco router, a 2811, which is an ISR G1. If I go into privilege exec mode and say show run all, that all option is going to show me the default settings. So, or a lot of the default settings. So when I say show run, right, you're not going to see 99.9% of the time. There are corner cases. You're not going to see the default settings, right? And you can see I've got all kinds of things configured here. But if you say show run all, you will see what a lot of the default settings are on the router. Okay, so show run all is another really nice command. And you can see I'm not seeing all of this in the running config because it's set default, right? These are default settings that you have here. Okay, and again, I'll leave it at that. So, because I want to make sure I caveat this in case someone knows about the all option and they're watching this and they say, no, that's not true. You could say all, and then you would see the default. And so when you say do show run without the all option, you are going to see all of the settings that you have, but 99.9% of the time, if you don't have all at the end of that command, you will not see the default settings. Okay, so we've got that configured as a trunk port, and I was going to show you this. So switch port trunk allowed. So let's say I want to be very, very specific here. What if I was to say 10, 20, 30, 88, 99 and hit enter. Now let's say do show run. Now you'll notice we didn't lose any points. We didn't gain any points. And what I just did there was I solidified the configuration on this switch on that trunk link. And I said that the only VLANs allowed to transit that trunk link are, sorry about that, went right by it, are 10, 20, 30, 88, and 99. Now you might be wondering, well, what about VLAN 1? Well, if I say do show interface trunk, and you can see right now VLANs allowed and active in the management domain. So it shows right now that only VLAN 99 is allowed. And we had to give it a second there, right? And you can see, so now it's updated. And you might be asking, well, what about VLAN 1? Because I've heard control traffic uses VLAN 1. And you're right, it does. And it will, irrespective of whether I shut down VLAN 1 or I allow it across this individual link. Control traffic for CDP, for VTP, for DTP will still come across the link, right? If in fact you've configured to allow that to happen. So I'm good right here. This is a very solid configuration. And we, excuse me, again, are not using VLAN 1 for transit traffic. So we don't want it on there. Okay. So all ports that are not assigned to a VLAN should be disabled. And it's very easy to see that. Now, a lot of learners will say, do show run, and they'll be like, okay, well, what ports are not in VLANs here? So, okay, 1, 2, 3, 4, 5. And then you've got to sit here and look at all these ports. And a much easier way to do this is to say, do show VLAN brief. Because ports not in a VLAN will show as being members of the default VLAN if they are not trunk links. Because let me ask you right now, in all of this output here, where is gig 01? To which VLAN does that belong? Where is that? You don't see it here, do you? And a close examination of the output of a show VLAN brief will confirm for you that the trunk ports on this switch, again, we have one, but the port gig 01 is not in the output here. And there's a very good reason for this that makes logical sense. Think about it. The definition of a trunk link is that it's allowed to pass multiple traffic for multiple VLANs. So if it's allowed to pass traffic for multiple VLANs, how could I put it into one of these VLANs? It doesn't make any sense because it doesn't belong and is not a member of an individual VLAN. By default, it belongs to all VLANs. And so that is why you don't see in all this output here gig01. It simply doesn't show up because it is a trunk link. And remember that, not only for real life scenarios, but for testing scenarios. Maybe you're shown the output of a show VLAN brief and asked, why is gig01 not show up here? And you may see choices like, oh, the port is broken, or the port is administratively shut down, things like that. That's not the reason. Again, logically think about it. The definition of a trunk link is that it allows the passing and the traffic of multiple VLANs, and by default, all of the VLANs. So how could I possibly put gig01 anywhere in this output? It just wouldn't make sense. And it doesn't make sense to put it here if that's what you're thinking, because think bigger scenario, think bigger picture. What if I've got multiple trunk links coming off this switch, all using different native VLANs? 100% possible to do. So then how would I know, right? If I put gig01 here and I've got two other trunk links that are using this as the native VLAN. And again, how do I know that it's the native VLAN? This is just a name. I could name it anything, right? Now, we've applied the statement to the port, so maybe that works, but I like the approach here of simply not listing the port because it really doesn't belong to a single VLAN, so it doesn't show in the output. So remember that. Back to the ports that aren't being used. Well, those are going to be in the default VLAN, VLAN 1. And so it's really easy, and here's the interface range command saving you a ton of time again. Interface range fast Ethernet 01 to 5, comma, gig02. So right now, whatever commands I'm applying will simultaneously be applied to every one of those ports. And so my command will simply be shut down. We wanted to shut them down, right? Yep. So shut down. There we go. And you can see the traffic has moved. I'm sorry, the completion percentage has moved to 93%. And let me say, are they supposed to be that are not assigned to disabled? It doesn't say they should be access ports. Let me confirm that. Switch port mode access. Okay, so that's not the case. Again, I just wanted to make sure they didn't want me to change all the ports to access ports and then simply disable these which are not being used. Okay, now it says configure Inter-VLAN routing on router 1 based on the addressing table. Now, this is an interesting ask right here because we have done the configuration on router 1. That has already been done, right? So now it wants to verify connectivity. Router 1, switch 1, and all PCs should be able to ping each other and the server. And so that's an easy test to run here. We'll pull PC 1 over. And again, you can see we're still missing 8 percentage points there. And so we're going to go back and take a look and make sure that we have everything configured. And I'm just looking back real quick to make sure that we've got all the steps have been taken into account. So let's ping 172.17.50.254. And then we'll pull PC2 up and we can go back and check. We'll give those a second or two because there's probably an ARP request that's going out right now. And let me show you what I mean by that. So here I am on PC2 and I say ARP A. And you'll notice that there's no ARP entries are found, right? Meaning I don't have any information mapping a layer 2 MAC address to a layer 3 IP address. In other words, when I say ping 172.17.20.1, I'm going to ping my default gateway. But you'll notice that on the PC, there is no ARP cache that already has the mapping that says, I know the layer 3 address I'm trying to get to. What's the layer 2 address that I need? And you can see I don't have that. So, and I'm hoping it didn't do what I wanted it to do. So typically what happens is you'll see request timed out here for the first one because it's got to get that information. But we can ping the default gateway. So now let's try to ping 172.17.50.254. And this is where we may get a request timed out because, again, I certainly don't have an entry on how to get to that layer 2 address. And so I'm going to go to my default gateway to get there. And you can see that it worked. If we go to PC1, and actually, I'm sorry, I put the wrong IP in there, so that is definitely going to fail. So with PC1, we'll put the 254 in there correctly. Let's close this out. Let's pull up the command prompt and let's say ping. And actually, let's go ARP-A. And you can see I don't have any entries, and maybe we get lucky here. And actually, I'm going to ping all the way out because that'll probably be a better opportunity to see that we end up with that request timeout. And that's what that request timeout is on that first packet. The first ping packet that goes out, I don't have the layer 2 information to map to the layer 3 information, which I'm asking to get to. And so we time out because I have to send an address resolution protocol request out. And I have to say, hey, here's the layer 3 address I'm trying to reach, right? I don't have any information for that. What's my default gateway? And then I don't have the default gateway in the ARP cache. And so then I get the information back that I need to go to 172.17.30.1. And you can see we've got connectivity. So we have connectivity all throughout the environment. I'm sure that something I configured that was extra may have been causing problems here. Let's say write mem. Okay, so we assign the IP address to router 1 and switch 1 based on the addressing topology. We configured the default gateway on switch 1. We create named and assigned VLANs on switch 1 based on the VLAN and port assignments table. And we did that. And did we do that? Let me double check here on the switch. Did I do them all? Show run. Or actually, show VLAN brief would be a quicker way. So did port 10 get the switch, the ports it's supposed to? Did 20? And did VLAN 30, and everything looks good there. And so, and they matched exactly. Configure gig 01 of switch 1 as a static trunk and assign it to the native VLAN. We did that. All ports that are not assigned to a VLAN should be disabled. We did that. We configured, so again, this statement here, configure Inter-VLAN routing on router 1 based on the addressing table. Well, if I come back over here to router 1, we can see show IP interface brief, that is in fact already done. The Inter-VLAN routing is done because we have configured the sub-interfaces. We have our native VLAN identified, and we're connected to the trunk link that goes to switch 1. And we verified the connectivity. So let me make sure we didn't overlook something here. Ah, okay, gig 180. Oh, so I put the wrong IP address. I did not notice that. All right, so let's close that out. And let's go back and take a look here on the router. We just did a do show IP interface brief. Ah, and I put the incap.1q statement and walked right by the IP address configuration. So 01.88, and this will happen from time to time as I'm doing explanations. We've already got our incap.1q 88 native statement there. So the IP address should be 172.17.88.1 with a subnet mask of 255.255.255.0. And now we reach that 100% mark. So my final comments to you will be, this is router on a stick. And for this design, it works beautifully. What if I didn't want to do router on a stick? Well, what I could do is get rid of this trunk link. And let's say that my router has gig 00, gig 01, and gig 02. I could do access ports on the switch and make this access port, switch port mode access, switch port access VLAN 10. And then I could make this one VLAN 20. And then this switch port mode access, switch port access VLAN 30 port, and run it to that physical. And these are physical interfaces on the router. Now you tell me, from a design perspective, in this use case right here, does that make sense? Or am I really wasting 2 gigabit Ethernet ports on my router. Yeah, I would argue that you're wasting 2 ports here. We're router on a stick because we don't have an oversubscription concern on this single gigabit Ethernet link, that this is a waste of ports. Now, again, it's all about the use case. I learned this from a triple CCIE by the name of Greg Stemberger, who I learned more than I will ever forget, or well, more than I'll ever know. I learned so much from Greg. But Greg always used to say, it's all about the use case. It's all about the use case. And that drives all of your design decisions. So let me say this. Let's say that we've got coming off here, and I'm just going to, these 3 links, let's say this is, maybe these are links to other switches, but behind all of that, I've got 300 hosts. All of those hosts have gigabit Ethernet connections that will all at some point aggregate and hit that individual router on a stick link. If we're still talking about router on a stick, does that make sense to do it like this? Or I'm sorry, to do it with a single router on a stick link? No, because we're going to completely flood that link. Does it make sense to do it like individual physical ports to do the inter-VLAN routing? And the answer is probably not. And so then we'd have to have a larger discussion about things, right? So again, you can do router on a stick, where we use a single port on the router. We could dedicate individual ports for each VLAN. That is not going to scale. Or if we didn't want to use a layer 2 switch, we could do a layer 3 switch, which is referred to as a multi-layer switch, a naming convention that I despise because it causes so much confusion. A layer 3 switch is a router, okay? That's how I look at it. And Russ White, who is one of the Cisco routing and switching legends, has said the same thing. And this is actually where I heard this first, a number of years ago, where he said that this was one of the worst decisions Cisco made, was calling layer 3 switches multi-layer switches. A layer 3 switch is a router. It just has a whole bunch of Ethernet ports on it, or, fiber ports, however you're going to configure it, right? So, but you could do a layer 3 switch, and you wouldn't need the router. The layer 3 switch replaces all of that. In fact, here, let me give you a better look here. A layer 3 switch, as soon as this clears for me, a layer 3 switch combines the functionality of the layer 2 switch and the router. So in this environment, I might argue that the better solution for this would be a layer 3 switch, because a layer 3 switch is still going to have a gig 0, 1 interface that we can configure. I'm sorry, I think this was gig 0, 0 going out to the internet. It's going to have a gig 0, 0 interface for an Ethernet connection out to the internet. And it's going to have individual connections for these switches. And on this multi-layer switch, I can configure VLANs to segregate this traffic if I wanted to, right? Because I don't have to enable inter-VLAN routing, but in our scenario, that's what we're trying to do, so we would do that. Excuse me. And so I can configure that on this single device, consolidating and eliminating those 2 devices. Now, again, it's all about use case. What if my connection to my service provider is a serial connection? Now, these are going away, but there's still, maybe it's a telco and it's a T3. A switch, right? A catalyst switch, typically you're not going to, I shouldn't say typically, you're not going to get a serial interface, a T3 capable interface that you can stick into a catalyst switch, right? Now, larger switches, you might be able to get away with that and find something, but we're talking about sort of a 3850 or a 9300, right? Typically, those are used at the access layer, not at the edge. So this is where use case will again come into play, where maybe now you have to do a router right? Because it'll support that T3 interface or a T1 interface. Now, those interfaces are going away and they're withering on the vine very quickly, being replaced by much faster Ethernet type connections. So maybe you don't run into that. But again, use case drives everything. All right, well, I think we have hammered Inter-VLAN routing into the ground about as much as we possibly can. My hope is that you really have a much greater understanding of how Inter-VLAN routing works and why you would do it certain ways as opposed to others, right? Those use cases we talked about and how that impacts your design in the real world. All right, well, this is going to complete Packet Tracer Activity 1.2.1 and this tutorial about Inter-VLAN routing. I'm really glad that you're taking the course. I hope it's adding value to not only your certification studies, your professional studies, but your career studies. Thank you so much for watching, and I will see you guys in the next video.